Hello, everyone. Wow, that's loud. I'm Andrea Ferris. I am the CEO of Intrinsic Advanced Materials. I'm a co-founder of the company and a co-inventor of our CiCLO technology. I'm going to tell you all about it today. And I am here with my colleague, Cheryl Smyer. Cheryl.
Hello, everyone. Cheryl, nice to meet you.
Just by show of hands, how many people have heard of CiCLO technology at this point? Okay, so about half of you. That's not bad. So CiCLO is a biodegradable technology, and it is designed very specifically to reduce fugitive synthetic microfiber pollution. So I'm going to start off with a 2-minute video, kind of a high-level overview of what CiCLO is. And then from there, we're going to get into all kinds of details about the history of our company, the problem that we're solving for, how the industry is defining it, how CiCLO is added to different materials, how we test it, how we market it. So kind of everything you might want to know about CiCLO technology. Looks like we're having a slight technical difficulty here.
What is CiCLO technology and how does it work? Welcome. I'm Sudeep Motapalli Rao, lead inventor of CiCLO, a sustainable textile technology. Synthetic materials like polyester and nylon are thermoplastics used widely in textiles for their durability, high performance, easy care, and affordability. But when we make these textiles, wear and wash them, tiny microfiber fragments are shed. These fragments have become a major environmental pollutant. Because these fibers are made from durable plastic materials, they cannot get broken down by natural microorganisms. So they persist in the environment, causing harm to the food chain. What's the CiCLO solution? CiCLO technology solves this problem by transforming the chemical nature and structure of these materials, making them attractive to microbes. CiCLO gets permanently embedded during the production of polyester and nylon, whether it's virgin or recycled. Thankfully, adding CiCLO to polyester and nylon does not compromise the durability or technical characteristics of the product. How does CiCLO work? CiCLO fibers contain biophilic active ingredients which attract microbes and provide them with nutrients and access points. These colonies grow as they create powerful microenvironments to break down and digest all the material. The microbes eat the carbon in these materials for energy and to build their cell mass like all living things. What remains are just natural elements like biogas and biomass. How is CiCLO tested? CiCLO is tested at independent third-party labs for chemical safety with EcoPassport certification by Oikotex, for efficacy using global standard tests such as ASTM and ISO methods, and for ecotoxicity to ensure environmental safety. So CiCLO delivers the same high-performance quality product but with a better environmental footprint. Learn more at ciclotextiles.com.
So I do want to share a little bit about the history of our company, because only about half of you raised your hands that you've heard of CiCLO technology, but we actually started developing this over a decade ago. And our story is that back in 2012, I was working at a uniforms company in the Bay Area, just outside of San Francisco. And we were running a huge uniforms program that was almost all polyester. And it was at that time that we decided we needed to make a better polyester for our own need. And then it was around, we kind of looked to see, was there anything in the market that could solve for the problems of synthetics, knowing that we needed to use polyester for a number of reasons. And we found there was nothing in the market specifically for textiles. So we hired a chief scientist who you just heard from, and we developed our own technology, which is now patented and trademarked all around the globe. It took us about 4 years to do that, and once we saw full biodegradation of CiCLO materials in labs, we decided that we'd created something really special, and instead of keeping it for the uniforms company, we should spin off a separate company and bring it to market so that the textiles industry at large could have access to this. So that's what we did. So we've been around for a while. We launched in 2017, and it was also around that time that we had the good fortune of meeting Parkdale Mills. And Cheryl is actually my colleague from Parkdale Mills, and we are a joint venture company with Parkdale Mills since 2018. And Cheryl, maybe you want to take a minute and talk about your introduction to us.
The interesting thing is that Parkdale, we're a yarn spinner, and so we also produce a lot of product, typically cotton, biodegradable wipes. And so the market, cotton is not really a good use for a disposable wipe, right? There's a lot that goes into that. So we thought we need to be able to biodegrade polyester and other polymers that are used in that single-use disposable market. So we started down the line of developing a biodegradable polyester. At the same time, we met Andrea and her team and thought, you have a technology that we're interested in looking at. So we vetted the technology for 2 years, did extensive testing, even produced everything from fiber all the way into fabric, and felt that it was the right technology to bring to market at a global scale. So we formed the JV in 2018, and since then I've had the fortune of working with Andrea together to be here with you today and travel the world and tell everyone why the CiCLO technology truly is a solution for microfiber pollution that we cannot fully prevent. And there's a lot of engineering and design around reducing the amount of microfiber that fabrics shed, but in reality, some of these fabrics will continue to shed a certain degree of synthetic microfibers. So that's where CiCLO comes in. And so we have developed a network of over 45 different fiber and filament yarn manufacturers around the world to bring CiCLO to yourselves, brands, fabric manufacturers that would like to adopt and use the CiCLO technology.
Thank you. So I'm going to cover a few statistics on this problem that we're solving for synthetic microfiber pollution, and specifically fugitive synthetic microfiber pollution. So once it's leaked into the environment. So they are really these minuscule fibers, defined as 5 millimeters or less in size, but it is a macro problem. And we really see no true end in sight. So I'm going to go through 5 numbers with you. So synthetic microfibers are the #1 form of microplastic pollution in all environments, including aquatic, atmospheric, and terrestrial environments all across the globe. And you can see this picture here. They're so tiny, right? We can't really see them, but they are all over the place. It's been said that up to 18 million microfibers can be shed during one load of wash. I've seen a number of statistics on this, and this is the highest I've seen, but that is a tremendous amount of tiny fibers coming out just from the act of washing, which is not the only source of microfibers in the environment. Microfibers from synthetic textile, just the act of washing, globally account for about 35% of the microplastics entering the oceans. And if you look at this picture in the upper right, those are little tiny pelagic crabs. They're about 25 millimeters in width, so about 1 inch. And you can see some blue around their claws, and that's actually microfibers, synthetic microfibers wrapped around their claws. So again, tiny little fibers, but they're really causing massive impacts. I do want to call out, and this was something that Charles mentioned to me when I presented at Functional Fabric Fair, that in Europe, there's a different statistic for the amount of the percentage of microplastics from textile microfibers. So in Europe, although the European Environment Agency recognizes 35% as a global statistic, here it's 8% of primary microplastics releasing to the water are from textiles. It's also said that the amount of synthetic microfibers entering the oceans annually is equivalent in weight to 50 billion plastic bottles. So we can't see them, but it's huge amounts of plastics entering the oceans. And lastly, many of you probably know this, but about 60% of all textiles globally are made of synthetics, and it's mostly polyester. So while we definitely believe that source reduction would be fantastic and that there are lots of really cool new materials coming to market, what we also see and think it's important to recognize that even with source reduction, there's no combination of other materials that could replace what we use for polyester today. So even with strides to do better, recycle more, use other materials, polyester is going to be here for probably our lifetimes, I would imagine, in some capacity. So this is a real problem. It's not going away soon. So we hear a lot about, of course, the washing of textiles as a major source for microplastics in the environment, but they do come from other places. So this is again from the European Environment Agency, but discarded fishing gear, a lot of fishing gear is nylon. There's pellet losses just from manufacturing, marine coatings, all kinds of paints have plastics in them, just the act of littering alone. Personal care products, and what I have circled here, of course, wearing and washing of our clothes. When we're just walking around, fibers are coming off of our clothes. They're shedding from our home textiles. Our carpets are largely made out of polyesters and nylons. Tires are a big source of microplastic pollution. And sewage sludge. So even the fibers from the washing that get trapped in sewage sludge are finding their way back into the environment because the sludge is being used as fertilizer on fields, or sometimes it's going also to landfill and being used as a cover. This is a lot of the same information, but kind of the percentage from each of these globally, from each of these different pathways. So globally, synthetic textiles #1, followed by car tires, then city dust. You can see further on, but it does surprise me that plastic pellets, literally from manufacturing the nurdles that we're using, there's enough of those in the environment, polluting the environment directly from manufacturing, that they make it on this chart. So the big problem here is, as we know, plastics aren't readily biodegradable. I don't think anybody knows exactly how long it takes plastics to biodegrade in the environment because we haven't been here long enough. And biodegradation, the act of biodegradation is affected by a lot of different factors, which we'll get into. But this is from World Wildlife Fund, and they have an estimate of how long different plastics would take to biodegrade in a marine environment. They call out plastic water bottles, which are the same PET grade that we use for our textiles, take about 450 years. So obviously this is a pollution problem. There's just plastic everywhere. But I think it's important for people to understand also that the plastic pollution, it's not just a pollution, garbage in our environment, but it also contributes to global warming. So if you consider these fibers, if they're just left to persist, they're a true danger to the health of our ocean. And what you're looking at here is a video, which is available publicly on Twitter, now X, and it's showing plankton, this is zooplankton, and it's actually choking on a synthetic microfiber. So the impacts, while we can't really see them, are quite large. Plankton are the base of the marine food web. They are responsible for removing CO2 from the atmosphere. They produce more than 50% of the oxygen that we breathe. And these microfibers wind up being like death traps for plankton. So the zooplankton can actually choke on them. And then from phytoplankton, they can block the sunlight. So they're everything is connected. It's not like it's just a pollution problem. Sometimes we hear from brands that they're just looking to, reduce their carbon or whatever it is, but everything is connected and we really need to deal with it all. So biodegradable plastics, which is what we're talking about here, biodegradable synthetics, biodegradable polyester, nylon plastics, can actually be quite controversial. And I do think it's important that we make it known our philosophy on, how and where biodegradable plastics should be used. So biodegradable plastics should never be designed in products that should end up in nature. That's not the purpose here. They're not a solution for waste management or littering, where it's not licensed to say, well, if something is biodegradable, you can leave it at the park, you can leave it in the ocean. It's all right to leave it somewhere and litter. But we do think that they're beneficial for materials that are leaking into the environment and that have leaked into the environment, and then we can't recapture them. We also feel that for any biodegradable plastics, it's really important that the marketing is truthful. And on end products, we need consumers to understand, well, what's the benefit of this? And how do we appropriately label it so that the benefit is understood, but the action of biodegradation isn't misunderstood? So we'll share with you how we approach that as well. The Five Gyres is a nonprofit organization that does a lot of research on marine pollution. They actually found 4 of the 5 plastic gyres in the oceans, hence the name Five Gyres. And I'm showing this from a recent report that they put out because I think they make a really good point, and especially as it relates to biodegradable plastics, in that when we're looking at plastic pollution and solutions for it, it's hard to make just sweeping generalizations and say, here's a solution and it's for all plastics in the environment. But instead, we need to look at the different applications and say, well, what do we need for each of these sectors? So they actually mapped this out. This came out just a couple of months ago. And they looked at the different sectors that are causing plastic pollution in the environment. And the idea is, well, let's say construction. The solutions for plastic pollution from construction aren't necessarily the same as from textiles or even from fishing gear, which might be a subset of textiles, but really looking at every application and saying, what makes sense here based on why do we need to use plastic here, and how is it ending up in the environment, and what do we need it to do if it does? So the CiCLO solution is very specifically designed for textiles, and it is, as we describe it, it's one solution to fugitive synthetic microfiber pollution. We certainly support, again, source reduction, new materials, better filtration, both at the home and the commercial level. But for the fugitive fibers that wind up in the environment, let's make sure they're not going to last forever. That's our perspective here. So that's a picture of the technology there. It gets added like a dope dye might to polyester or nylon. It can be added to recycled or virgin during the melt extrusion. And what it essentially does is it embeds countless biodegradable pathways throughout the whole matrix of the fiber. And these pathways do a few things. They act as nutrients for microbes that naturally live in the environment. So they have something that they're attracted to. It's a nutrient for them. And it also ever so slightly creates some amorphous regions, reduces the crystallinity the slightest bit, and also increases the hydrophilicity a little bit. So for biodegradation of anything to occur, you need moisture and microbes over extended periods of time. And so we're allowing over time moisture to attack the material a little bit more than it would normally, and also the food for the microbes. And so microbes seek it out, and they're able to build colonies and break down the material. They break down the CiCLO material, but also the surrounding polymer. We test for the biodegradation in environments where we have moisture and microbes over periods of time, but also where synthetic microfibers are prolific pollutants. So in wastewater treatment plant sludge, where they get stuck in the digesters, natural seawater conditions, natural soil conditions, so not commercial compost conditions, but actual natural soil conditions, and anaerobic landfill conditions. any materials made with CiCLO, it maintains the durability and the recyclability. So again, going back to our roots, we started this for uniforms, and we needed the uniform shirt that we were developing at the time to be just as durable if it didn't have anything else in it, because that's really the most sustainable thing we can do, right? Design for longevity. The product is also fully traceable. So Cheryl touched on our business model. We sell our technology only to our certified manufacturing network, of which roughly 45 around the globe. So those are nylon and polyester fiber producers. They are certified. We have legal agreements in place. They stand behind the quality of the fiber that they sell, and they're also required to participate in our traceability program. So we know that every lot of fiber that is produced with CiCLO has the correct amount of CiCLO in it, and a certificate of authenticity is issued for that. There's a lot going on this slide, but this is showing you a case study of biodegradation comparison of a CiCLO treated material versus the same material without CiCLO in it. And we're looking at the different environments that we're testing in. So the first bar across the top, the dark blue one, is CiCLO polyester and seawater. So this was at about 3.5 years. So this doesn't happen super quickly. 3.5 is way better than never. And we see full biodegradation at about 3.5 years. The light blue bar below it, which says 5%, is that same material, but didn't have the CiCLO in it. So we test these things side by side to see, in the same conditions, CiCLO versus non-CiCLO, how much faster will it biodegrade? So 5 versus 94 in about 3.7 years. In an anaerobic landfill type condition, and this would be a biologically active landfill, so there would be some moisture in the landfill. We're looking at 91% at 3.5 years versus 6%. In soil, these are ambient soil conditions. Again, they're not commercial compost conditions, but considering that if a fiber winds up in maybe the sludge and then it gets turned out into the soil as a fertilizer, we see 91% at 3.2 years versus 3% for the non-CiCLO version. In wastewater treatment plant sludge, 90% at 2.6 years versus 0 for the non-CiCLO polyester. And then the last bar is, this is actually the material is still in test. We're looking at 1 year, it was 360 days. And this is an additional seawater test that we're doing on the same material where it's includes seawater and sediment. And it's kind of like mimicking where the ocean meets the sand. And so just corroborating our data on the same materials. And at 1 year, it's 38% and continuing to grow. And the non-CiCLO is at 1%. So greatly accelerated rates of biodegradation in all of these natural environments. The tests that we use are ASTM and ISO standard test methodologies, and they're respirometry. So what they're measuring is actually the gases that are respired from microbes when they digest materials, and this is the true indication of biodegradation. So microbes break down molecular chains, they digest the material, they give off biogas, and they use some of that carbon also to build their own cell walls. And because they use some of the carbon to build their own cell walls, and it's measuring respirometry, this is why you never see these tests actually hit 100%. 90% or more is considered full biodegradation. We often get the question about, well, what about in situ testing? And are these test methodologies, is this what's actually happening in real life environments? And if you think about an in situ test, so if we took a piece of fabric and we took it out to the sea and we kept coming back to check on it, gases cannot be captured. So any mass loss we can't actually truly attribute to biodegradation. We don't know. There could be all kinds of mechanical action or any kind of disintegration happening. And the other thing about in situ testing is that if you think about these natural environments, they're living systems, and it's endless combinations of environments that we would wind up in. So like, how do you even define what is an in situ test, right? These materials, they are transient. They might be going through the washing machine. They're going into the wastewater treatment plant. They're going through the sludge. They might wind up in soil. They might be washed out to the ocean. And so in situ testing is really, really difficult to, even try to determine what would that test look like. So really, in summary on the test methodology for biodegradation testing, we do believe that we're using the very best available test methods. These aren't test methods that we made up ourselves. They, again, are ASTM and ISO standardized test methods. These methods, like most test methods, have been established by technical teams. It represents academia, commercial labs, industry. They take years to develop. They're periodically reviewed. They're periodically updated. So for instance, the seawater one, which is an ASTM D6691, it was initially published in 2001. It was revised in 2009, and then again in 2017. So, these are very relevant tests. And between all of the tests that I mentioned, we're looking at aerobic, anaerobic conditions, and we're looking at various temperatures as well. So speaking of temperatures, the tests are typically warmer. So the soil one is an ambient temperature. The seawater test is run at about 28 degrees per the ASTM test method. It's warm. And I can't tell you how many times we've gotten the question of like, well, 28C, come on, the oceans never hit those temperatures. But actually they do. So this is just from earlier this summer. This is from the New York Times in Florida. It was 90s Fahrenheit in the oceans off Florida, really, really warm. We know that our oceans are literally warming. And then this is a map. You can find this on seaworldtemps.org, something like that. Any given day, you can see what's the spread of temperatures throughout the oceans. And if you look at the purple, the pink, the dark reds, we're looking at 27, 30, up to 35C. So the oceans do actually get really warm. I pulled this from 2 days ago, and we update it periodically, but the oceans always have these warm temperatures, and the colors actually move around with the seasons. I think this is my last slide on biodegradation, but I think it's important to also recognize that there are so many factors that can affect the rate of biodegradation. The important thing to us is that the material is inherently biodegradable, and it can and will biodegrade over time if it has moisture and microbes. But some things from the environment that can affect the rate: temperature, moisture levels, the presence of oxygen, light, so UV breaks down plastics, all kinds of plastics, mechanical abrasion, diversity and density of microbes in the different environments, and then also the material properties. So we have crystallinity, moisture regain, structure surface area, finishes, all kinds of things can make something biodegrade faster or slower. Probably the number one question we get is, how long will it take? And I just took a long time to tell you that basically we can't tell you how long it's going to take. But what we can tell you is that we have testing that shows that CiCLO polyester breaks down at rates similar to wool. So we ran a side-by-side test. This was wool, and it happened to be a recycled PET with CiCLO in it. And they're breaking down at roughly the same percentage. So a lot of our marketing will say, like natural materials like wool. So that sums up really the biodegradation testing and our perspective on it. But the important takeaways there are that the time it's going to take for any biodegradable material, cotton, wool, CiCLO polyester, in uncontrolled natural conditions is going to vary. Fugitive microfibers, they're transient. They may not end up in conditions where it's really, really ripe for biodegradation. They might take a long time to get to those conditions. They might wind up in those conditions and then somehow be blown out to a desert where they have no moisture and they stop biodegrading. Same with anything that's biodegradable. So making claims on how fast something will biodegrade or that it will always, always fully biodegrade, because we don't know where they'll go, we have to be careful with our claims. But what we can tell you is that CiCLO technology allows fugitive synthetic fibers to biodegrade at greatly accelerated rates compared to the comparable fibers without CiCLO technology in it. So marketing, would you like to cover this?
Sure.
Please?
Let's talk a little bit about marketing. So how do we tell the story on such a complex product, right, and topic? And so number one, we use very responsible marketing. There are regulations, both in some EU countries, in particular France, and also in the state of California, state of Washington, that regulate consumer-facing claims that can be made about how a synthetic material can be talked about. And so, first of all, a biodegradable product should not mean that it is disposable. We're not creating or encouraging that something could be disposable just because it is biodegradable, right? It is basically an insurance policy. I hate using that word, but if a product ends up, microfibers end up in the environment as pollutants, then with CiCLO they will biodegrade. So we don't use any language that is misleading or that we would consider greenwashing, or recently I heard the term green hushing. I don't know if anybody has used or heard that term recently. I thought that was a new one, right? Where you tell half the story. Well, that's pretty much greenwashing as well. So in certain, specifically in the United States and in some countries, you cannot use the word biodegradable on your claims made around the product. So we don't use the word biodegradable. Instead, we focus on the end benefit. What is the benefit of using a CiCLO product? So I'll take your attention to the top right corner. That is the back side of our hang tag. And it says CiCLO technology reduces the persistence of fugitive plastic microfiber pollution in our environment. So we work with our brands directly to develop messaging that's important and relevant for their specific consumer. Different iterations, small iterations of that statement are acceptable, and so we work with them to make sure that their claims are legally compliant. It is also important to substantiate your claim with data. So CiCLO, we have invested a lot of resources over the last 10 years in confirming the efficacy and the biodegradability of the product. And so for all brands that we work with, we offer all of our biodegradation test data and go through it at length. And we take pride in the fact that we really are the leading technology in our space. We have proof of no microplastic, proof of non-toxicity in ocean water, and biodegradability in those 4 environments that we've talked about. It's important to talk about how to care for the product, how to dispose of it if it cannot be recycled. And lastly, any of the brands have access to our marketing information through a very simple trademark licensing agreement. There's no cost to use CiCLO or the brand. We do not have any type of licensing program. Anyone can use CiCLO. And then let's wrap it up and tell you one more time what we just told you over the last few minutes. CiCLO is available globally through our network of certified partners. We are not bound by exclusivity. We don't work with anyone on an exclusive basis. We believe here at CiCLO that it should be available to everyone because it really takes a combination and all of us together to combat microfiber pollution. It is affordable. There are many new technologies that come into the market. They may not be scalable and they're very expensive. So here at CiCLO, we have gone through great lengths to make sure that Our additive chemistry can be injected into a recycled or a virgin polyester or nylon, both in a continuous polymerization process as well as an extrusion process. It is obviously testing, it is trusted. We have a traceability program. It has its own tracer, so at any time, the fabric can be tested, the yarn can be tested to ensure that it contains CiCLO. It is Okotex EcoPassport certified, REACH compliant, and we consider ourselves a full-service brand in that we work with the retailers, the brands, and the entire supply chain to make sure that everyone understands how the product should be responsibly marketed. And Andrea spends a lot of her time educating NGOs and understanding the solutions like CiCLO that exist to make sure that the community that are in the thought leadership space and are really discussing what are the next innovations in the textile industry, that they understand what CiCLO is.
Okay, I think that's all. So we'll leave you with the thought that inaction really maintains the status quo, and we can make an impact together. And I'd be happy to answer any questions.
Much more importantly, before we get to any questions, if you were struggling to keep up with that, I've heard it before. And the more I hear it, the more sense it makes. But can we show our appreciation for the two of them on stage to start with? Then we'll get on to questions.
Should we start again?
No.
How many times
No. It's because there's several layers of understanding. And I'm going to fill until I say a hand for questions. But I'm not going to talk synthetic. I'm going to talk cellulosic. And we know that your average pair of jeans is 73% cellulosic, 27% chemical because of pesticide, herbicide, and fertilizer. But the pair of jeans that came out of USS Central America, was it, Mark? The SS Central America, auctioned in Sotheby's, New York, just before Christmas, $114,000. Had been under the water, shallow, warm, oxygenated water for over 100 years. Mm-hmm. And when we all know cotton biodegrades, isn't it? That's what we learnt at school. They didn't have synthetic chemicals to dye it over a century ago. They pulled it out. They were highly recognizable as jeans. Mm-hmm. So without going to the level of synthetic materials, even on natural materials, they are not decomposing like we learnt at school. Mm-hmm. They need something to help them, of which CiCLO works very well. Yeah. So I'm still I'm looking for a question at hand to go up. But yeah, that's why I like the technology. But I've got Dr. Mark Taylor. I've been waiting
for Mark. I knew he'd have a question.
Well, it's Charles's fault. He talked about the Central America. And we know that they pull fibres that in laboratories biodegrade easily, and then they pull them out of the bottom of the ocean, and they're there, so they're not biodegrading in that environment. So will additives like CiCLO and others out there, will they work in that realistic environment as opposed to in the laboratory?
Yeah. So we kind of covered this on a few different slides. Yeah, so I mean, we definitely couldn't argue the fact that the rate of biodegradation in different environments is going to vary wildly. Really what we're looking for is to give the polyester the opportunity to biodegrade in an accelerated period of time versus never. But do realize we need microbes, moisture, has to be exposed over periods of time. Warmer temperatures are going to help. Normally, I'm not quite sure why a pair of jeans didn't biodegrade in a warm ocean and why it was there 100 years. I'm confused. I don't know anything about those ones, but there are conditions that are going to be more ripe than others, and these are transient fugitive materials, and that's all we're looking at.
I hate to correct Charles, but he has a lot of stuff going through his head, and sometimes he does make slight mistakes. It wasn't shallow and warm. It was the Atlantic off the coast of North Carolina, so it was cold and dark. But also, on the same shipwreck, they found a waistcoat, and there's an academic paper from about 20 years ago about the analysis of the biodegradation of the waistcoat, and that had bits that had been dyed, and they'd suffered 0% cellulite biodegradation, and the undyed components had suffered less than 3% biodegradation after 136 years on the bottom of the Atlantic. So there are issues there, and I think when I ask these questions, I just want people to be aware that these solutions are great and that we need them, but they're not perfect, and I think that's the point.
100% agree. We think this is a better solution. It's not a perfect solution. There's going to take a whole host of solutions, and we have to use them all in combination.
You do have a question.
Thank you. One question, does the CiCLO needs to be part of the actual apparel, or could it just be thrown into the ocean and would biodegrade or break down the textile, the microfibers that are there?
It needs to be embedded in, if I'm understanding your question correctly, it needs to be embedded in the actual fiber, like putting it in the ocean and that material coming in contact with other materials wouldn't be intimately enough connected to actually allow other things nearby it to biodegrade.
It has to be in the molecular structure of the polyester, because if we think about, these are teeny, really invisible microorganisms to our naked eye. So they would digest the polymer, right, and then turn it into an oligomer and into a monomer. And at that point, that's when they can actually digest it and respire the biogas. So it has to be at the molecular structure.
The customer gets paranoid if they buy a decomposable garment. It's going to fall apart whilst they're wearing it, or they come to the wardrobe next spring and it's gone. You've got to have the combination, coming back to what Andrea said earlier, about you need the microbes, you need the heat, oxygen activates it. So only if you leave it covered with fresh dirt, that's the easy way, will it actually disappear. And Charles is filling me again, and I have another question. Christine, thank you.
Hi, thanks for the presentation. I'm wondering about the dyes and the finishes that are added to the CiCLO polyester. Does it mean that these are all also digested and biodegraded?
So we do see dye stuff biodegrade in our lab tests. If there are finishes on there that are non-biodegradable, let's say you have a material and it's coated with a non-biodegradable coating of some sort, those things aren't going to biodegrade. So, I mean, it's really chemistry by chemistry. Different finishes can also affect the rate of biodegradation. We've done some testing on, for instance, a couple of different antimicrobial finishes and then testing the finished fabric. And what we see is that the biodegradation in lab studies is stunted at the beginning, but then it eventually takes off. So it affects the rate. We've tested a couple of DWR finishes and haven't seen any problem with that. You didn't ask this, but we do also get questions about toxicity of different finishes and biodegrading in the environment. We always recommend using safe dyes and chemicals, Okotex, EcoPassport, Cradle to Cradle. Certainly if there's toxic materials on a material and it winds up in the environment, we're adding toxic materials to the environment. We shouldn't do that. That's a no-no. But yeah, so we have to kind of consider that finish by finish, but we do see dye stuffs biodegrade as well.
Thank you.
Hello. I have a question. Just what would happen if you had to wear a garment that had a CiCLO treatment together with a natural garment in close contact with it? You would want to break down the CiCLO garment. You'd want it to biodegrade over time, but the natural garment, you'd want to try and get as much lifetime use out of it as possible. What's the impact there?
Thank you for that question. So the biodegradation will not occur until you have moisture and microbes and the material is in contact with those over a period of time. So if we think about, even let's just take an undyed cotton t-shirt or an undyed unfinished wool something, those materials are inherently biodegradable, but they're not going to start biodegrading if you went swimming in them for a few days. So the process, the natural process, takes some time to even get started. And it's because you need moisture and microbes over time, it's not going to happen while you're wearing them. It's not going to happen while you're manufacturing them. It's not going to happen when it's sitting in your closet. So it really has to be in really these environments we've explained, like soil, seawater, wastewater treatment plant, sludge, the activated sludge, or the sludge in the digester. So yeah, it won't biodegrade.
You mentioned a few times, both of you, that in the process there is a production of a biogas. What kind of gas is this, and which impact does this gas has on the environment?
So biogas is a natural byproduct of biodegradation of anything that's biodegrading. So it's not specific to CiCLO. So when wool biodegrades, when cotton biodegrades, when a banana peel biodegrades, there's going to be gases generated. And the natural gases in an aerobic environment, so in our tests that would be in the seawater and in the soil environments, is carbon dioxide. And in the anaerobic environments, if we're looking at wastewater treatment plants, sludge digesters, and anaerobic landfill conditions, it's going to be a combination of methane gas and carbon dioxide. The methane gas that is generated in an anaerobic digester on site at a wastewater treatment plant is captured 100% and used for energy, or there's even people who are taking that methane and turning it into biodegradable plastics like PHA. And then at landfill, where if it's a biologically active landfill, so you need moisture and microbes in there, the gases at modern day landfill are required to be flared or captured for energy. So, and we're not advocating that things should be going to landfill anyway, but that's what will happen if it's biodegrading in a landfill. The microfibers that are biodegrading in, say, the oceans or in soil, they're so small, and the amount of carbon dioxide that would be generated from the biodegradation of them is insignificant, especially in comparison to the damage that these microplastics are doing in the environment.
I got one more. As far as I know, the main problem of the microfibers or the fragmentation occurs during washing. Now, if we have the textile being washed, or what does the addition of the microbes and of the whole, of the treatment makes to the garment that it's washed? And on the other side, if it doesn't make a change during washing, why should I add something just for the case that this garment would end up in the ocean? I'm just trying to go.
So,
Could I jump in here? You're factually incorrect. We lose more fibers during dry durability than washing. Fact. So anywhere you're going to lose fibers, which can be wet or can be dry, you've got something to answer what you call, I mean, I love that expression, how you've labeled your microfilaments coming off. So it's any case they come off, they're either waste to society, or if they've been CiCLO'd, they're going to disappear. But I'll let you guys answer it as well.
yeah, I'm not sure if you were also asking, does the addition of CiCLO create more microplastics, more microfiber shedding? And we have done studies on CiCLO versus non-CiCLO, same fabrics, to make sure that there's no unintended consequence of additional shedding using AATCC methods. And we don't see any additional shedding. So it doesn't cause more shedding is one thing. There are studies that show that the microfiber shedding from manufacturing of textiles is tremendous as well. The Nature Conservancy did a study, and they called out that for every 500 shirts manufactured, 1 is lost as microplastic pollution. So this is where filtration is so important, I think, at the commercial level. also at the home level. There are also studies that show that our household dust, I think it's 6 kgs per year that the average household produces of microplastics in your dust. So they're coming from everywhere.
So does it make sense to add the CiCLO to fabrics that would be coated or laminated afterwards?
Can you say that again? That would be...
Whether it makes sense to add the CiCLO or to use CiCLO in fabrics that are intended for like laminated or coated fabrics?
Mm-hmm. So if you have a fabric that is coated with something that is non-biodegradable on both sides and microbes can't access the fiber underneath it, then we wouldn't expect there to be any biodegradation efficacy. And I would also expect something like that probably wouldn't have a lot of microfiber shedding.
Danielis, don't stick up your hand, otherwise I'll give you the microphone. I can see no more hands. Can I once again ask us to show our appreciation for the CiCLO team, please?
Thank you.